Hello and welcome back to part 2. Here we study in detail individual ocean currents like the North Atlantic Drift, the Gulf Stream current, the currents in the Pacific Ocean. What are their influences? How do ocean currents influence the temperature of a place, the climate of a place? And what happens when cold and warm currents meet? So this is the second part of this video and I hope you will enjoy studying this part with me as well. So here I again just put up this map to show you the different kind of ocean currents you're going to study. This is the Atlantic Ocean. You have the North Atlantic gyre and the South Atlantic gyre. Gyre means a circulation of currents in a circular motion. In the northern hemisphere they go in clockwise motion, in the southern hemisphere they go in the anti-clockwise motion. You have the Pacific Ocean here and there's Japan up here on the side. So you have the North Pacific gyre which goes in the clockwise direction and the South Pacific gyre going in the anti-clockwise direction. This is a gyre in Alaska also. And then you have the Indian Ocean here, the Indian Ocean gyre. Okay, there's only one here. There's one on top and one on the bottom, but this is the more important one. If you notice, this water body is much huger than this water body, right? So the Pacific Ocean has a bigger surface area of water for the currents to flow. So let's move ahead and study this chapter together. Let us go one step ahead and look at now the different ocean currents in the oceans of the world. You have the Atlantic Ocean, you have the Pacific Ocean, you have the Indian Ocean. Let us start with the currents of the Atlantic Ocean. Now if you look at the Atlantic Ocean, it is present here between North and South America and Africa. The currents are divided into two parts, the North Atlantic Ocean and the South Atlantic Ocean. So the North Atlantic current and the cold Atlantic, the South Atlantic current. Now, currents in the North Atlantic Ocean, the ocean currents are marked in yellow. Yellow are all warm currents. Red are all cold currents. So if you're asked to name warm currents in the North Atlantic Ocean, then this is the North Atlantic Ocean. Start with the North Equatorial Current. The equator is here. There is the current above it is called the North Equatorial Current. The one below it is called the South Equatorial Current. And you have a counter equatorial current. So you have the first one is, in the list is the North Equatorial Current, which is this one. It's flowing in this direction. Then you have the Antilles Current, which is here. Then you have the Florida Current, which is here. You have the Gulf Stream Current, which is here, which is very important current. Then you have something called the North Atlantic Drift, drifting more towards the north. And around Norway, it becomes the Norwegian Current. So these are the 6 currents, ocean currents, warm currents in the North Atlantic Ocean. Warm currents have a different role to play. Cold currents have a different role to play. And when the warm and the cold meet, something happens there also, which is very important because there are many give reasons for questions, which answer is a north and a cold are meeting. You have the Labrador Current coming from here, which is a cold current. You have the East Greenland Current coming from the side of Greenland. It is a cold current. And you have the Canaries Current. It is also a cold current. So if you're asked to name 2 or 3 currents, cold currents in the North Atlantic Ocean, then it is the Labrador Current, the East Greenland Current and the Canaries Current. What is interesting is these currents, they are flowing in a kind of a circle. Why are they flowing in a circular pattern? Because when a current flows like this, it has a land mass, it gets deflected. That is, this land mass gets deflected, then deflected. Whenever there's a land mass in its place, then deflect again and goes like this. Some turn around and come like this. Wherever there is a land mass, it deflects the ocean current, and this circular motion of a current is called a gyros. It will come ahead, I'll teach you that. So when this current from here, the Labrador current, the cold current, and the warm current of the Gulf Stream meet here, it's called the Grand Banks, this area. Why? It will come later, I just want to bring it up now. When a cold current and a warm current meet, 2 things happen, one good and one bad. The good is they give rise to planktons, small creatures that are food for fish. So lots of planktons are found here, and that's why this area is very good for fishing. It's called the Grand Fishing Banks. The negative is When a cold current and a warm current meet, when cold and warm meet, what happens? Condensation. Fog is formed. Very thick fogs are formed. And ships lose their way. They go and hit against icebergs and they sink, like the Titanic. For now, just learn the names of the currents in the North Atlantic and that is the warm currents and the cold currents. All right, fine. So now the currents of the North Atlantic Ocean. We're focusing on the same. I'll keep bringing the same map down so that there is continuity for you. Okay. In what direction do the ocean currents in the northern hemisphere move? The direction they move in the northern hemisphere, it becomes the opposite in the southern hemispheres. So in the northern hemisphere, if you look at these ocean currents, they are moving in a clockwise direction. So they move in the clockwise direction. What are these ocean currents? Name the main ones. The Gulf Stream drift. This is the Gulf Stream drift. It originates in the North Atlantic Ocean. From Cape Hatteras, it moves as the Florida current. This is Cape Hatteras. From here, it starts as the Florida current onto the south of the Great Banks or the Grand Banks. These are the Grand Banks. This is their southern area, southern part. So from the Cape of Hatteras, it comes as the Florida current and moves on the south banks of the south area of the Grand Banks, the Great Banks. And in this part, it is called the Gulf Stream drift. It is one of the strongest ocean currents in the world. If you are asked to name one of the strongest ocean currents in the world, you should know it is the Gulf Stream drift, where in the North Atlantic Ocean. This is the North Atlantic Ocean. In the geography maps, you've got this. Mark the oceans in that Atlantic Ocean is there. This is the North Atlantic Ocean. And the Gulf Stream drift, which lies to the south of the Grand Banks, is the strongest ocean current. So, in what direction do ocean currents flow in the northern hemisphere? Clockwise. Southern hemisphere, anti-clockwise. It will come to that. Okay. Now we continue with the second current. The first one we did was the Gulf Stream drift. The second important one is the North Atlantic drift. Where does it originate? It originates in the Gulf of Mexico. You may be asked, where does it originate? If you were asked what is the origin of the Gulf Stream drift, you should say Cape of Hatteras and Florida current. If you are asked the origin of the North Atlantic drift, you should be able to say this is the Gulf of Mexico. It originates from there. Okay. The Gulf Stream flows eastwards, forming the North Atlantic drift. Origin is Gulf of Mexico, formed by the Gulf Stream drift. That is moving. This is going toward, this is the east, this is the west, this is the east. So the Gulf Stream drift, when it moves towards the east, it becomes the North Atlantic drift or North Atlantic current. It is deflected eastwards at the Cape of Hatteras due to the rotation of the earth and the westerlies. So it starts from the Cape of Hatteras like the Gulf Stream drift, and it is deflected. By our currents deflected? We have read that earlier. Currents are deflected because of the rotation of the earth's rotation on its axis, and the westerlies, the winds. You have the westerlies here. It deflects it this side and it becomes the North Atlantic drift. So it reaches, this is Europe. It reaches Europe as the North Atlantic drift. It is one of the most powerful currents that carries warm equatorial water northwards. So if these are equatorial waters, these waters are carried by these currents. So one of the most powerful currents that carries the equator water becomes warm, carries warm equatorial waters northwards at the rate of 15 kilometers per day. So the North Atlantic current or the North Atlantic drift has 3 diversions. Why? Because from the North Atlantic Ocean, the North Atlantic drift or the current divides and flows in 3 directions. Now learn this. What are the 3 directions? Can you see? Britain is here. It flows eastwards to Britain. It flows northwards to Scandinavia, the Scandinavian countries, and it flows southward to the cool Canary Islands. It is called the Canaries current. This question comes in the exam almost every year. Into what 3 diversions does the North Atlantic drift divide into? You should be able to think in the map. Auntie is telling us, one from Usha auntie, is flowing this way. So it is flowing here as the Gulf Stream becomes the North Atlantic Drift. It moves towards eastward. Direction is important. Eastwards towards Britain. Northwards towards the Scandinavian countries is called Scandinavia. So east, north and southwards toward the Canary Islands called the Canarian Drift, the Canaries Drift. It is not, it's going east, it's going north, it's going south, it's not flowing westwards. So it's flowing in three directions. Remember the three directions and towards which countries it is flowing to. The Canary Islands are very beautiful. Name the famous fishing ground in this area. The Grand Banks, this part is called the fishing grounds in this area. It's also called, this area is called Newfoundland, just above the fishing banks, the Grand Banks. So name the two currents that meet off the coast of Newfoundland. You should be able to say the cold Labrador current and the warm Gulf Stream drift. You should be able to say cold and warm. It's very important because warm and cold are meeting. That is why you have this fishing grounds here. Okay. Because when warm and cold currents meet, planktons are formed. Planktons are able to survive and multiply in large numbers, and planktons are the food of fish. So the famous fishing ground in this area, the Grand Banks, learn that. Then name the two currents that meet off the coast. This is Newfoundland. The currents that meet here are the Labrador current, the warm Labrador current. Yes, no, please learn it properly. The current, all these currents are the warm currents. It's coming from Alaska. It's coming from the Arctic. It can't be warm. Those coming from the equator are warm. From the Arctic are cold. The cold Labrador current meets the warm Gulf Stream drift in this area called the Newfoundland. Okay. So this map continues. What are the Grand Banks? The Grand Banks are the famous fishing grounds in the Newfoundland area. This is the Grand Banks. This area is called Newfoundland. So the Grand Banks are the famous fishing areas in the fishing grounds. It's called a fishing ground. It's not a ground actually, but it's the sea, but it's called fishing grounds in the Newfoundland area where the cold Labrador current and the warm Gulf Stream drift meet. So the cold Labrador current and the warm. How do you remember cold and warm? The ones coming from the equator are warm, from the Arctic are cold. Now, give reasons for. Very important. Two reasons can happen. Give reasons for when a cold and a warm current are meeting. First, the Labrador current is responsible for productive fishing grounds, or the Gulf Stream drift is responsible for productive fishing grounds, or why are the Grand Banks so called? The Labrador current is a cold current found in the North Atlantic Ocean. It drifts down eastwards to meet the South Stream drift, the Gulf Stream drift. So a cold current is meeting a warm current. Okay, so it drifts southeastwards, it drifts to meet the warm Gulf Stream drift. The meeting of the cold Labrador current and the warm Gulf Stream drift causes fog, 1, and 2, favors the deposition of planktons. Learn these terms. Deposition of planktons. Doesn't favor production of planktons. Deposition of planktons. Planktons get deposited there. Planktons are food for the fish. This gives rise to the famous fishing grounds called Grand Banks in Newfoundland. So say the cold Labrador current meets the warm Gulf Stream drift here. And this causes fog formation as well as the deposition of planktons in that area. Everybody knows planktons are fish food. This gives rise to the famous fishing grounds called the Grand Banks in Newfoundland. Second give reason for, the coast of Newfoundland is found to be dangerous for navigation because along the Newfoundland coast, the warm Gulf Stream drift and the cold Labrador current meet. When a warm and a cold meet, they cause fog. This fog makes it difficult for ships to see other ships. They have difficulty in navigation. The Titanic sank in that area because it hit an iceberg. Navigation. Its navigators could not see, in the fog they could not see what was ahead, and there was a huge iceberg. It just banged into it and everybody died. So, two questions, same answer. When a warm current like the Gulf Stream drift meets a cold current like the Labrador current off the coast of Newfoundland, there is formation of fog and deposition of planktons. The deposition of planktons causes these areas to become fishing grounds. The formation of fog makes it difficult and dangerous for navigation in these areas. So now there are more give reason for questions. Okay. Ports of Western Europe can be used in winters too because why? Ports of Western Europe are here. This is Western Europe. Okay. So let us look at this slide. Okay. We were just talking about how the ports of Western Europe can be used in winters also. Generally, you will think that ports will get frozen in the winter. Western Europe is here. Why? You have this warm drift coming, a warm ocean current coming. So, because at approximately 40 degrees north, the Gulf Stream flows eastwards, forming the North Atlantic current. You have to write this. The Gulf Stream forms the North Atlantic current. The North Atlantic current divides into three parts: Britain, Scandinavia, and the Canaries, right? So it reaches Europe as the North Atlantic drift. This is Europe, the North Atlantic drift. It is one of the most powerful currents that carries warm equatorial waters northwards. Three keywords: warm equatorial waters. You can't just say it is a warm current and it goes and makes that place warm. No, it is a warm current, but it carries warm equatorial water, 1 point, and most powerful current, 2nd point. So it is one of the most powerful currents that carries warm equatorial waters northwards. This is northwards, and keeps the ports of Europe free of ice. So we did give reasons for earlier. Why is this a fishing ground? Because a cold and a warm current are meeting. Why is it bad for navigation? A fishing ground because planktons are deposited. Bad for navigation because again the cold and the warm current, when they meet, fog is formed. But for ports of Europe, it is this North Atlantic drift that is one of the world's most powerful currents that brings warm equatorial waters to Europe and keeps its ports free of ice. The ports of Norway are free of ice in winter. Okay, this is the Norwegian area. While Greenland, this is Greenland, same latitude. Greenland that lies in the same latitude is bound by ice all year long. It depends now on which ocean current is coming to Greenland and which is passing by Norway. We know this is the Norwegian area. The North Atlantic drift becomes the Norwegian current, which is a warm ocean current. So let's read it why. The warm North Atlantic drift that flows along the coast of Norway prevents freezing. The warm North Atlantic drift becomes the Norwegian current. It flows along the coast of Norway and keeps it from freezing. The cold East Greenland current that flows along the coast of Greenland, this is a cold current. The cold East Greenland current that flows across the coast of Greenland, the east coast of Greenland, brings down temperature further and contributes to ice-bound areas all year long. So both these are in the almost same latitude, but this is warm and this is cold. Why? Immediately you should say the one warm must be having a warm current flowing past it. The one cold must be having a cold current flowing past it. So Norway has the Norwegian current, which is originally the North Atlantic drift, which is very powerful current bringing warm equatorial waters to Europe. And this is the East Greenland current, that is a very cold current. So it keeps Greenland cold and frozen. Lovely explanation. Eastern coasts of USA are comparatively colder. Why? Well, this is the east coast. These are the east coasts of USA. Why? The cold Labrador current keeps this east coast. This is the east coast of USA. All this, east coast, you have Boston, MIT, Harvard are located there, New Jersey. So the east coast of USA is comparatively colder because of the cold Labrador current. What does the cold Labrador current do? It brings cold waters and therefore it cools the climate of those areas lying next to it on the continents. Okay. So this is a very important part of this chapter. What is the importance of these two North Atlantic region currents? One is a cold current, one is a warm current. So what is their importance? The importance of the Labrador current. The Labrador Current plays a major role in influencing the climate of the Canadian areas lying around its path. This part of the continent of North America is Canada, and the Labrador Current has a very important role in the in affecting the what do you call it, the climate of these regions. Okay, that is the first part. The relatively low salinity means salt content of the current makes the waters easily susceptible to freezing. When the salt levels are less, water can freeze faster. So the first point to remember is it influences the climate of the Canadian region lying along its path. Its low salt levels makes the water easy for freezing. The cold waters of the Labrador Current have a moderating effect on the climate of the coastal lands in its path. Because it is cold, summers are cooler and winters are more severely cold. So it has a moderating effect on the areas lying in its path. Summers are cooler, winters are very cold, okay, severely cold. The numerous icebergs in the path of the Labrador Current often acts as a barrier to the safe passage of ships. Why is the safe passage of ships in this area dangerous? So the Titanic sank in this area. The Labrador Current is very cold and there are numerous icebergs in this area, making it difficult for ships to go easily in this area. So it's this area where the Gulf Stream meets the Labrador Current, fog forms, navigation is tough. But purely in the Labrador Current area, icebergs form. They are bad for ships. Now the importance of the Gulf Stream drift. The Gulf Stream drift is here. The warm Gulf Stream is a strong ocean current that brings warm water from where? From the Gulf of Mexico into the Atlantic Ocean. The North Atlantic drift is a strong current that brings warm equatorial waters. The Gulf Stream comes from here, from the Gulf of Mexico. So the warm Gulf Stream is a strong ocean current that brings warm water from the Gulf of Mexico into the Atlantic Ocean. So they ask you, where does the Gulf Stream originate? It is the Gulf of Mexico. Okay. It influences the climate of the East Coast. This is the East Coast of America, including Florida, and then North America, keeping temperatures here warmer. So winters are cooler and summers are also cool. So winters are more moderate here. Now it warms, then it travels this way, the Gulf Stream, it becomes a North Atlantic drift, and it warms the Western European countries. This is the Western European countries, the west of Europe. Okay, these points are important. So the next question that will be asked of you is, how does the Gulf Stream drift affect the climate of northwestern Europe? First of all, you must know the location of northwestern Europe. 1. 2. You must know what kind of an ocean current is it. Is it warm or cold? Accordingly, you can answer. Now, at approximately 40 degrees north, the Gulf Stream flows eastwards. It's very important to say eastwards. The word eastward is important. This is east, forming the North Atlantic drift or current. It reaches this part of Europe. Okay, it reaches Europe as the North Atlantic drift. It was one of the most powerful currents carrying warm equatorial waters, and it warms the Eastern European countries and keeps the ports of Europe ice-free. Whether they ask you about the North Atlantic drift or the Gulf Stream drift and its impact on this part of Europe, the answer remains the same. Very warm, they're very strong currents carrying warm equatorial waters to Western Europe. So these countries are warmed up, as well as their ports are kept freeze-free or ice-free in winter. What is the Sargasso Sea? Very important. Within the ring of currents, within the ring of currents in the North Atlantic Ocean, which are these? The North Equatorial Current, the Cayenne Current, the Antillean Current, the Florida Current, the Gulf Stream, and the Canaries Current. A large amount, this North Atlantic drift has gone there. So between this loop, this is called a gyre. A large amount of floating seaweed collects. The water goes round and round. Those are the currents. The word seaweed is important. A large amount of seaweed collects, and this area of seaweeds is called the Sargasso Sea. Which is it? The part of the sea lying within the ring of currents. What are these 5 currents? The North Equatorial Current, the Anti-L Current, the Florida Current, the Gulf Stream, and the Canaries Current. This has gone up here. Okay, lies a large amount of seaweed. This is called the Sargasso Sea. It is right in the center of the Atlantic and has no perceptible current within the circle of currents. Inside it, there is no current. So what is the Sargasso Sea? It's a large amount of floating seaweed found in the North Atlantic Ocean. In the circle of currents, name the currents. Okay. A very interesting question. Which current completes the clockwise circuit of ocean currents in the North Atlantic Ocean? We have seen the North Equatorial Current, the Florida Current, Gulf Stream, the Canary Current. Till here it has come. This Canary Current flows clockwise and southwards, merging into the North Equatorial Current again, forming a gyro. Gyro is a circular pattern, clockwise circuit of currents. Remember, in the northern hemisphere, currents flow in a clockwise pattern. Now in the southern hemisphere, they move in an anti-clockwise fashion. In the South Atlantic, in which direction do the ocean currents flow? Anti-clockwise. What lies between the North and South Equatorial Currents? This is the North Equatorial Current. This is the South Equatorial Current. North of equator, south of equator. In the middle lies the counter equatorial current. Remember that. And it is east flowing. Remember that. This is the equator. This is the North Equatorial Current, South Equatorial Current, and counter equatorial current that flows eastwards. Okay. What are the ocean currents of the South Atlantic gyre? Gyre means this circular current. There are 4. This is the equator here. The South Equatorial Current, it is warm. The Brazilian Current, which is also warm. The West Wind Drift, which is cold. And the Benguela Current, which is cold. These 4 form that circular pattern in the South Atlantic. We did North Atlantic earlier. Now this is South Atlantic. So I've just shown you this picture of the North and the South Atlantic currents, North and South Pacific and Indian Ocean next to India. Above they're all clockwise, above the equator. Below the equator, anti-clockwise. Red is for warm current and green is for a cool current. So we just did ocean currents of the North Atlantic Ocean or the Atlantic Ocean, North and South. We did both of those. Now you have ocean currents of the Pacific Ocean. Specifically, they're important for Japan. I'll show you a picture of that. Now, to the left of America, North America, is the Pacific Ocean. The North Pacific Ocean, the South Pacific Ocean. So you have the North Equatorial Current, the South Equatorial Current, and the counter equatorial current. All of them are there. Okay. In the Northern Hemisphere, the North Pacific currents are like this. They flow in a clockwise direction. South Pacific flow in an anti-clockwise direction. They emerge from the North Equatorial Current and the South Equatorial Current. Okay. Now, name the following. The warm North Pacific Ocean currents, all yellow. North Equatorial Current, fine. Kuroshio Current, fine. North Pacific Current, fine. And the Alaska Current, it's going towards Alaska. These are the 4 warm North Pacific currents. Name the cold North Pacific currents. Red in color. The Oshottis current here, the Oshottis current. Then the Oashio or Kamachatka current, very important current. And the California current, towards the coast of California it flows. These 2 are going to bring cold water. Something interesting is going to happen here. These are going to flow and turn into a cold current, back into a warm current. Name the following warm South Pacific Ocean current. So now South Pacific Ocean currents. South Equatorial Current is warm, and East Australian Current flowing towards the side of Australia is a warm current. Cold South Pacific currents, the South Pacific Current, the West Wind Drift, and the Peruvian Current. You have to remember these names, children. Memorize them properly. Peru because South America, there's Peru here, so Peruvian current. All right. So now we come to the questions on the ocean currents of the Pacific Ocean. Now, why is there a modification in the patterns of circulation of currents in the Pacific Ocean? Or why are the ocean currents in the Pacific area different? Look at it. The amount of water movement is much bigger than what is here in the Atlantic Ocean. This is huge open space for water to move. So because of extensive size and openness of the Pacific Ocean, right? You should know that they flow clockwise on top and anti-clockwise on the bottom. So why are these currents? Why is there a modification? Modification means change. When you hit land masses, currents have to change their direction when they hit land masses. The land masses are far away here. There's more water, more ocean. So because of extensive size and the size of the extensive size of what of the Pacific Ocean, see how wide it is, and its openness of the Pacific Ocean, these ocean currents are special. They are different. Name the currents of the Pacific Ocean. Currents in the North Pacific Ocean, we just wrote them in the previous slide. The North Equatorial Current, the Kuroshio Japan Current, the North Pacific Drift, the Oyashio Current. Where is it gone? The Oyashio Current. It's a cold current. It's also called the Cold Alaskan Bering Current, Cold Oshkosh Current, and then the warm Kuroshio Current is here. They both meet off Hokkaido. The cool Californian Current. Currents in the South Pacific, South Equatorial Current, warm East Australian Current on the east coast of Africa, West Wind, Drift, South Pacific Current, cold Humboldt, also the Peruvian Current, and back to the South Equatorial Current. So the currents names please memorize. So now comes the part with Japan. Which current is it that pass? This is Japan. These are all the islands of Japan. Name the warm ocean current that flows along Japan. What is its role? The warm ocean current that flows along Japan is the Kuroshio current. The red currents are warm, the blue are cold. So the warm Kuroshio current is the warm ocean current. Learn this name, Kuroshio, S-H-I-O current, is the warm ocean current that flows along Japan. What is its importance? Warm ocean currents transport warm water towards the polar regions. Japan is towards the polar regions. It transports warm water northwards towards the polar regions in the form of the North Pacific Drift. So the warm Kuroshio current becomes the North Pacific Drift, and its role is to take warm water to the polar regions, the Arctic regions. Okay. What are the other two names or three names of the Kuroshio current? The Kuroshio, the Black Stream, and the Japan current. How is this Kuroshio current useful? Or state the importance of the Kuroshio current. First of all, you should be able to say it is a warm ocean current. Now, it sustains the coral reefs. Coral reefs, the coral will die in cold water. Warm water sustains the coral reefs. Second, when the warm Kuroshio current mixes, here's the warm Kuroshio current, here's the cold Oyashio current. When the warm and cold meet, what happens? Fog and planktons. Okay. When the warm Kuroshio current meets with the cold Oyashio current, it causes fog and deposition of planktons, giving rise to great fishing grounds off the coast of Japan. This part near Tokyo, this area where these two currents meet, you have fantastic fishing grounds, deposition of planktons, and you have fog. It transports warm water northwards to the polar region, keeping the Alaskan coast ice-free even in the winters. Alaskan coast ice-free in the winters is the job of the Kuroshio current. Coasts of Western Europe ice-free is the job of the North Atlantic drift that turns towards it and becomes the Scandinavian current. So remember, don't get confused. Alaska, Greenland is cold because of the other current, East Greenland current going next to it. Here we're talking about Alaska. So Alaska, Arctic region, is the warm Kuroshio current. It transports warm water northwards to the polar regions, keeping the Alaskan coast ice-free. European coast ice-free is the North Atlantic drift. This is the Pacific Ocean current, the Kuroshio current. Remember that. So we come to the exciting part of the Pacific Ocean. Give reasons. The Alaska coast is free of ice in winter because it's important to write warm ocean current, not cold. So warm and cold has to come. From the warm North Pacific drift, warm water flows along the Alaskan coast towards the poles. These warm waters keep the Alaska coast free of ice in winter. So name the current if you want, the Kuroshio current, which becomes the North Pacific drift, goes up and takes warm water with it that flows along the Alaskan coast towards the poles, keeping it ice free. Japan is famous for its fisheries because I just showed you Japan. Two currents are meeting there because the cold Ayashio current and the warm Kuroshio current meet off the coast of Japan near Tokyo, causing fog and deposition of planktons. Because of the causing of deposition of planktons, this gives rise to great fishing ground in this part of the sea. Therefore, Japan is famous. If you ask for fishing ground, you should know when cold current and when warm current are meeting, deposition of planktons, fish are happy, fish breeding grounds. Okay. The South Pacific cycle of currents attracts large shoals of fish because the South Pacific cycle, not meeting of cold and warm, it's attracting shoals means it's a collective noun, groups of fish. Why? It is rich in microscopic marine plants and animals that attract the shoals of fish. Then learn this answer. The South Pacific region has thick layers of guano, which is valuable as a fertilizer because. Same reason, the South Pacific region is rich in microscopic marine plants and animals that attract the shoals of fish. So first, that area has marine plants and animals that attract fish. Birds gather to feed on the fish and their droppings form thick white layers of guano and whiten the coastal cliffs and islands. So those areas look white from a distance. Why? It's bird shit. We need to learn it. Why is there bird shit there? This South Pacific region, North Pacific region is the Alaskan one. These two are, this is the North Pacific. This is where two warm and cold currents meet. This is where the South Pacific Ocean, the cycle of currents, attracts a lot of fish because this area is rich in microscopic plants and animals. Fish come there to eat on those. Birds come to eat the fish and keep shitting everywhere. Their droppings form thick white layers of guano and whiten the coastal cliffs of islands. If this question comes, you have to give all the answers. This region is rich in microscopic plants and animals. So shoals of fish get attracted. So birds come to eat those fish and their droppings cause this thick guano. The Chilean and Peruvian coasts are practically rainless. Why? I showed you the coast of Peru, South America, west coast. Because the South Pacific current, obstructed by the southern tip of South America, is forced up the western coast of Chile on the Peruvian current. The cold water of the Peruvian current chills that area, and the winds keep the Chilean and Peruvian coasts free of rainfall. So you must know this. Why are these coasts practically rainless? Because the South Pacific current gets obstructed by the southern tip of South America. So it is forced along the west coast of Chile as the Peruvian current goes up. It's going up like that. Remember, we saw it going up. Now the cold water of the Peruvian current chills those areas along with the winds, keeping the Chilean and the Peruvian coasts free of rainfall. So what is the importance of the Peruvian current? We just saw it in the previous slide. The Peru current, the cold water of the Peruvian current chills winds that blow onshore. A current is flowing across the coast of South America, a Peruvian current, and the winds that blow over it get chilled. This makes the Chilean and Peruvian coasts practically dry and rainless. So when a wind blows over a cold current, it is not able to pick up moisture. So it does not bring rain. It brings dryness and no rain. The ocean currents in the Indian Ocean do not follow the pattern of currents in the Atlantic and Pacific Ocean. Very important. Why? The direction of currents depends upon the winds along as well as the land masses in their way. Okay. The monsoon winds play a major role in controlling the circulation of ocean currents in the Indian Ocean. So the currents in the Indian Ocean are affected by the blowing of the monsoon winds. So they are not similar to the those in the Atlantic or the Pacific Oceans. Explain the effects of ocean currents on the following. The climate. Ocean currents modify the climate of the region along which they flow. How? Regions near warm ocean currents or warm water currents are warmer and wetter as compared to regions near cold ocean currents. How? The winds blowing over the warm currents pick up moisture. The ocean currents are warm. When the ocean currents are warm, they'll start making the water evaporate. The winds blowing over that will pick the moisture and take it over the land. Okay? And they pick up the moisture and bring rain. While those winds that pass over cold ocean currents, there's no evaporation happening there. So they don't bring any rain, but they make the deserts colder and drier, like the Kalahari Desert in Africa. Navigation. Dense fogs are formed by the meeting of the cold and the warm ocean currents, and they can be dangerous for ships as they reduce visibility for navigation. Example, the Titanic sank in 1912 due to poor visibility caused by the cold Labrador Current and the warm Gulf Stream drift. They both met and caused dense fogs, and the Titanic could not see the icebergs in its way. Third, economic activities. The mixing of cold and warm currents causes planktons to be deposited, raising fish in that area, the numbers of fish in that area. So now people have activities, they go fishing, they sell the fish and they earn money. So they promote all the fishing activities in abundance. It enhances economic activities. Economic means income earning activities. People are now able to become fishermen, go out, fish, sell the fish and earn money. So ocean currents affect the climate. How? By bringing rain if they are warm and winds blow over them, or making a place rainless and dry if they are cold with winds flowing over them. For navigation, they spoil navigation. They create dense fogs where a warm and a cold currents meet. They promote economic activities like fishing in places where the cold and the warm ocean currents meet. So this is the last slide of our study. It is the effects of ocean currents with examples. They influence the climate. Ocean currents modify the climate conditions of the coastal regions along which they flow. Example, the Gulf Stream drift. It brings warmth to the coasts along which it passes, and when winds blow over it, it brings rainfall. They pick moisture and bring rain. Winds that blow over warm ocean currents pick moisture and bring rain. Example, the North Atlantic rain drift brings rain to the west coast of Europe. We saw how it goes towards the west coast of Europe. The Kuroshio current brings rain to the east coast of Japan. Dense fogs. When cold and warm currents meet, they form dense fogs, which are dangerous for ships as they reduce visibility for navigation. Poor visibility caused by the fog formed by the warm Gulf Stream drift and the cold Labrador current caused the famous Titanic to strike an iceberg in 1912 and sink. So they influence the climate. They pick up moisture and bring rains. Like the North Atlantic drift brings rain to the west coast of Europe, and the Kuroshio brings rain to the east coast of Japan. They form dense fogs. Ships can sail faster if they follow or sail the direction of current. If you flow in the direction of current, you have no opposition. You can go faster. Then, while the opposite direction hinders their speed. Okay. Planktons and fishing grounds are formed. The mixing of warm and cold ocean currents helps in the deposition of planktons, generating good fishing grounds. Like the meeting of the cold Labrador current and the warm Gulf Stream drift causes fog also and favors the deposition of planktons, giving rise to the famous fishing grounds called the Grand Banks in Newfoundland. Very easy. And here we have just a recap of all the currents I have taught you today. North Atlantic Gyre, North Equatorial Current becomes the Gulf Stream, becomes the North Atlantic Drift. Where does this originate? Gulf of Mexico. And then the Canary Current. The South Equatorial Current flowing anti-clockwise, the Brazil Current. And then it becomes the West Wind Drift and the Venezuela Current. This is in the Indian Ocean region, and this is in the Pacific region. I hope you've enjoyed this chapter with me. I hope it's been fun to understand the currents. It's been easy for you. Remember how the cold and the warm meet and what happens? Which currents keep which coasts cold, which coasts ice free? Coast of Alaska, which one is keeping it warm? Just remember the names of the currents. Some belong to the Pacific Ocean and some belong to the North Atlantic Ocean. Understand that clearly.